data out of the plot. But if you say plot exact like rise in price or stocks or sun changes, for example, let's say the last example, how sun changes periodically every few years. I have actually plotted this for my assignment in my master's time. So this is basically the blue lines are basically how sun's temporal rotation actually works. So as you can see, in the x-axis is the year, and in the y-axis is basically the latitude. So as you can see, there are some spots where sun's rotation is less, and there are some spots where sun's rotation is a bit more in the white spots. And the white dots are basically where sunspots were found. And as you can see, there is a correlation between the faster rotating places and the places where the sunspots are found. So that's why we plot, right? So this is one reason what we plot, and we can get meaningful inferences. So with that, without further ado, I think I've already taken like 8 minutes. So in 9 minutes to be precise. So now what we are going to do is we are going to introduce you to Matplotlib. So what is exactly that? So it is like a library in Python. We have to import it and then we can use it. So we are basically used for plotting primarily, but it also has some mathematical functions and some image processing things. I mean, I won't go very complicated into it. It can be used for a variety of things. It's a very versatile library. And it also can be used with many other libraries like NumPy, Pandas, etc. So, and without further ado, now that we have seen what and why and how and exactly how do we plot, so we shall now do some live practical demonstrations of it. Right. So first, what do we do is we need data, right? So what do I do is I generate data. So I use first import documents. So we import the library. So I first import NumPy and I import Matplotlib. I think that should be sufficient for now. And from that I import just pyplot because I don't need any for this exercise I won't need anything else. So I just import that. Right. So now I run this and I imported all these libraries essentially. So now what I do is I generate data. So first I generate x is equal to some. So let's, for simple reasons, let us plot a sine function. So I generate the x-axis from minus pi to pi, and I take 100 points in between, and I then take a sine of all these values. Now I plot this. So for plotting, what do we do is we write this command plt.plot and the variables. For now, let's see what we can do further. But yeah, for now this should work. So I run this by pressing this arrow, or you can also press shift and enter. Now as you can see, we are seeing the sine curve, but then I see some random line here. So this is basically, it's a script which basically is a Matplotlib script. So basically, if you are not using the Jupyter notebook or something, it will just pass this script out. But let's say if I am not using Matplotlib, like a Jupyter notebook, but then still I want to print it, like you want to show the figure, so I need to basically write another command, plot.show. So this will actually output the image, and yeah, so this is basically our basic plot without any extra things. So this is the basic plot. But now if I just show this plot to some external person, they will like, what plot is this exactly, right? So I need to first draw the x and y axis. So I first do that. So x line stands for so basically this Google Colab also uses the autofill command, so I'm using it. So just a minute. Yeah. So AXH line stands for horizontal line, and AXV line stands for vertical line. So I also, because the axis should not jar with yeah. So I basically run this. Now you can see we have drawn the axis, and now we need to label the x and y axis. So for that we basically write plt.x label, and plt.y label. And the title of this will be angle basis sine of it. Now if I run this, now I get the actual the plot, which looks a bit more refined, right? So yeah, so basically this is how, this is one basic how do I put it, yeah, this is one basic way of how to get a plot. But then not always you will find we will have to generate these images, so sometimes we will get the data from some other outer source. So, and also one more thing I forgot to do is, if you want to basically scale reduce these white portions here and here, we can always limit the axis to the maximum of x and the minimum of x. So this will basically scale the plot. Okay, just a minute. Yeah. Yeah, it will basically scale the plot it will basically, it will reduce the empty space, which for some, like if you want it to not have empty space, you can use this, right? So not always you will get the, we will have to generate the plot. Sometimes you'll get the plot from some experiment, or from some data, some simulations, etc. So to get that, so what I have done here, I'll just do it again. Okay, I downloaded by mistake. So what I do in Google Colab, so I have to either upload this file, so that basically what I'm doing is, I need to make sure the notebook can access that data. So if you are using Jupyter Notebook locally, or say if you are using it in a cloud like Colab or Jupyter Lab, you will have to make sure you can access this data. So what I do is, with open sine.dat, comma read, R stands for read, for line in file. Wait, I forgot the colon. So I basically split it into basically I'm taking the data, I'm extracting, this step is basically I'm extracting the data out of it. I mean, there are actually a lot of ways which we can extract data. We can also use np.load text and then do it. But this I'm used to it, so I find it very, like, I'm used to this thing. So it might be a bit inefficient. So bear with me. Right. So now that I have the data, now I plot it again. Just a minute. Just a minute. Yeah, but I think there is some issue with the scale, but just a minute, just a minute. Yeah.
I think it's axis label that's too dense.
Yeah, yeah, yeah. I think that's what I realized. But yeah, just a minute. Yeah. So I think I can change that. Let me just check whether the data I have taken is right for the first place, so that I don't. I sure. Okay, just a minute. Sorry for the inconvenience.
It's fine. I think it's fine.
Yeah.
Well, maybe.
Yeah, I think it's the axis label as you said.
I see. I think the type of
Yeah.
data is wrong. Looks like it's string rather than.
Yeah, yeah, yeah. So I need to actually write float of parts instead of just yeah. That's actually right. Yeah. So it's a rookie mistake. Yeah, that I think this should work. Yeah, that works. Yeah.
Very good.
So yeah, sorry, it's a mistake from my side. So always the data comes in string. So yeah, mistakes like happen. So I'm sorry for that. Yeah. So as you can see, most of the times the split comes in string. So you will have to sometimes either convert it to float or int, and then you will have to plot it, right? So yeah, so we can. I mean, you might ask like, why should I define YL to be some sign of that? I can just directly define it from as some directly get it from Excel, right? And yeah, figures out you can do it. So you can always use Matplotlib, NumPy, and SciPy together. So it's not everything. Right. So now that now one last thing I want to demonstrate is error bars, because sometimes in experiments you will get obviously we get errors. So Walter Lewin has said a measurement without error is absolutely meaningless. So we are going to demonstrate how to put error bars. So we put plotted error bar np sin xl and then x error. For now, we are putting 0.2 because this is a simulated data. So I'm assuming uniform error, but usually you will get error data along with the measurement. So if we plot this, as you can see these lines, right? So these lines are the bar in the region where the point could lie. It's the line which basically the average place where the point is lying. But this point can lie either here or here or anywhere in this line, this small line, right? So that is basically one way of looking at this. So to finally close this, so we are gonna just look a glimpse of the 3D plot. So for 3D plot, what I'm gonna do is I'm gonna generate a random matrix. So I generate something called ran is equal to np dot random dot rand, and I show the dimensions of it, and I print this. So this is the matrix, and I'm gonna basically use the ImShow function of Matplotlib, which basically plots it like an image. It's a pixelated image. As you can see, this is, you can sort of say 3D plot because this is x and this is y, and this value will be the value of z. Now what I do is I am going to show you how to do a contour plot. So if so plt.contour gives you a contour plot. So as you can see, these green lines are the places where the values are supposed to be equal, but as you have kept a 4x4 matrix, it just assumes like continuity and then it plots the contour. So this is one contour plot, and there's also a function called contour f, which is contour field, which fills basically colors inside these contour lines. And as you can see, this is one more where you can show 3D plots in a paper. So we will also generate one more random plot, and I will show you. So you can keep playing with these, and yeah, so that's one way we can what we can do. So with the last 7 minutes, I will show you what the assignment I have prepared for you. I know, I mean, assignments are usually of a thing, but yeah, I'll just show you. It's a simple assignment. Don't worry about it. Again, first I will import this. So this is just a warm up. This is just to revise on what we did just now. So this is something called the Hertzsprung-Russell diagram. So what it exactly gives you? Yeah, as usual, I forgot to upload the data. So first we will always have to upload it. And now we run this. Yeah. So this graph is basically shows you how a star evolves, right? So this blue region is when the hydrogen is burning. This orange region is when helium is burning, and the green region is when the helium is completely burnt. And this AGB, or the asymptotic giant branch, is when all the other elements are burnt. And this purple line is the white dwarf phase of a star. So basically, we can interpret a lot of things about a star with this HR diagram. So this is just a revision of whatever we did now. This has everything on what you need, right? So if I said something like don't change anything in this cell, it will be nice if you don't change anything so that the program runs smoothly. So the two exercises I have, which I think that is basically a warm up. This is just a solved exercise. So exercise 2 is a discrete Fourier transform of a noisy signal. So yeah, so what basically happens is, a lot of times you will get noise in your data. So basically you will have to do basically clean up the noise, and one way to clean up noise is a Fourier transform. So if you want to learn more about it, I have sent a link in this notebook only. You can click this and learn more about it. So you can just, what you have to do is you just have to plot these data which come, and you have to see how things change. So I would have told you what exactly to plot as well, so nothing to worry. You can always follow from the first point, and then yeah, you can figure this out very easily. The third one is basically plotting of electric potential for different systems. So here what we do is we basically use a so-called Poisson solver, which uses a Poisson equation. Like, Poisson equation gives you the potential for any given system. So there are a lot of ways in which we can code a Poisson solver. So this is one method called successive over-relaxation, which I have also given the reference to. So there are two systems. You will have to just plot it and just say what system it is. So it can be a quadrupole, it can be a dipole, it can be a point charge, etc. You can always look into the net and you can always answer it. But yeah, the main this is the identification is not a problem, but you just have to plot and see what exactly it is. You can use IM show, you can use contour F, or you can use contour, etc. That's up to you, right? Yeah. So with that, I would like to end my session. So thank you.